Hey there, you ever look at some crazy long decimal and just wish you could snap your fingers and turn it into a nice, clean fraction? Well, guess what? Today, we're going to learn the mental math shortcuts to do exactly that. Let's dive right in.
Okay, so take a look at this. At first glance, it just looks like a whole mess of math, right? But believe it or not, hidden inside all of this are a few incredibly simple patterns. And our goal today is to pull this apart piece by piece so you can see those patterns too.
First things first, we've got to build a solid foundation. So we're going to start with the decimals you're probably already pretty comfortable with, the ones that have a nice, clean ending. They're called terminating decimals.
Let's just warm up with an easy one, something like 0.8. You might kind of feel like you already know how to do this, and that gut feeling, that's exactly what we're about to turn into a foolproof method. Check out this super simple 3-step trick using 0.65. First step, just say the number out loud, the proper way, 65 hundredths. And here's the cool part. You literally just said the fraction. So step 2 is to just write that down, 65 over 100. And the last step is just a little cleanup. You simplify the fraction and boom, 13/20ths. That's all there is to it. All right, that was the easy stuff. Now let's get to the really fun part. We're going to tackle those weird decimals that just repeat forever. This is where the big aha moment is going to happen. So what do you do with a number that just never ever ends, like 0.22222? You can't just stick it over a 10 or 100. There's got to be a different kind of rule for this, a different pattern, right? And you're absolutely right, there is. We call it the rule of nines. And honestly, this is like a secret weapon. It lets you instantly turn any single-digit repeating decimal into a fraction. It's so simple, it almost feels like cheating. If we look back at that first image, we can see this rule playing out right in front of us. 0.1 repeating is 1/9. 0.2 repeating is 2/9. 0.3 repeating is 3/9, which, simplifies down to 1/3. Are you seeing the pattern here? It's so simple. Whatever number is repeating, you just put it over a 9. Okay, let's try one. Using that exact pattern we just found, what do you think 0.777 repeating would be as a fraction? Go on, take a guess.
Yep, that's it. It's just 7/9. It's really that easy. And the best part is, once you see this pattern, you can't unsee it. You can now do this in your head for any single repeating digit instantly.
Okay, so right about now, you might be thinking, that's a cool trick for one digit, but what about the really messy ones with more than one repeating digit? Well, I've got good news for you. This beautiful little pattern, it just keeps going. So how does the rule grow? It's actually really intuitive. For one repeating digit like 0.555, we use 1/9, right? So we get 5/9. So what happens if two digits are repeating, like 0.5858? Well, you just use 2 nines. It becomes 58 over 99. See how perfectly that scales up? And this pattern doesn't stop. So if you have a 3-digit chunk that's repeating over and over, yeah, you probably know exactly what's coming. You just put that 3-digit number over 999. And we can see this exact thing back in our original image. The decimal, 0.435 repeating becomes, you guessed it, 435 over 999. It's the same simple idea, just with more nines. Okay, let's pull all of this together. In just the last few minutes, you have added some seriously powerful new tricks to your mental math toolkit. So here's a quick little cheat sheet for everything we just learned. For those simple terminating decimals, you just say it, write it, and simplify it. For a single repeating digit, you pop that digit over a 9. And for multiple repeating digits, you put that repeating block over 99 or 999, and so on. And that's really the big takeaway. These aren't just a few random tricks. These are powerful patterns that give you the ability to handle a huge range of decimals and turn them into fractions, all inside your head. So we've basically just uncovered the simple, beautiful logic hidden behind numbers that look really complicated. It really makes you wonder, doesn't it? Now that you can see these patterns, what other mathematical secrets are just out there, hiding in plain sight, waiting for you to find them?